definition, and then they have unnecessarily complicated life. So
Indeed.
I want to point out where life is very simple, but unnecessarily, you have stretched it out to many, many steps. What can be done in like one step, or it's too obvious maybe. Sri Bhavani, have you raised your hand?
Nobody has raised their hand. Arun is
okay, it's my cursor which looked like that.
All right, have fun. Bye.
Bye. So the moment I move the cursor to one of the people, it becomes a hand. So yeah, I'm ready. Let me know whenever we can start. Is everybody in? Okay, I'm guessing everybody is in. Okay, one request. When you send in your question, answers to the homework, most of you do not mention your name. And then, today we got another set, which is an updated version. So it's a bit difficult to correlate, okay, which one has been updated to what. So it will be really appreciated if you just mention your name either in the file name or somewhere in your homework. Okay, just so that it's easier to figure out from whom it came. Is that doable?
Yes, okay.
Okay.
Yes.
Okay, so instead of going through what each of you have done, I think I have gone through them. What I will do is I will just share my PPT, which has some stuff already, and the rest will get filled up as we go. Okay, so let me share screen. Okay, I hope this is, the font is big enough so you can read everything. Right? So this was the homework. Okay, now what we want to do is first we really need to figure out what are the definitions. And let me tell you that there can be more than one way to defining some of these. And you can choose your definition. Okay, so how would you define a rectangle? And you can either unmute and say, or you can type it in the chat. As I said, there are more than one possible way to define, and they're all correct. So,
All angles are 90 degrees.
huh?
All the angles are right angle.
All the, okay, a quadrilateral with all angles. Okay, if we say all angles are equal, will that do? If we say all angles are, yeah, because see, all angles are right angle automatically means that they're equal, and it also tells you what is the value of each angle. Now, since we already know generally for quadrilaterals that the angle sum is 360, if we know all angles are equal, from there we can deduce what is the value of each angle. Okay, so this is one possible definition. What else?
Opposite sides are equal.
Opposite sides are equal. Okay, now if you have opposite sides are equal, you may get something like this. This one also has opposite sides equal. Is it a rectangle?
No.
Hmm?
Parallel, opposite sides are parallel.
Okay, this one has opposite sides parallel.
Include that angle also.
Yeah, so if you want to say opposite sides are equal or opposite sides are parallel, then that is not sufficient. You need to have something more to get to a rectangle, right? So how can you start from opposite sides are equal to get to a rectangle? You have to say something else. Let's say opposite sides are equal, okay? And then you need to put an and something. What will that and be?
Leg angle should be 90 degree.
And you can say one angle is right angle. If you say that, then that will work. Okay? So basically, when you are saying opposite sides are equal, or if you are saying opposite sides are parallel, again, you need to say that and one angle is right angle. Then essentially what you are saying is that parallelogram with a right angle. That's what you are saying. Okay? These two basically mean the third one. Okay? Opposite sides are parallel is the definition of parallelogram. Okay? So that's essentially the next one. Okay? And opposite sides are equal is an equivalent condition for parallelogram. Meaning if you have a parallelogram, then its opposite sides will be equal. If you have a quadrilateral whose opposite sides are equal, then it has to be a parallelogram. Okay? And I think both proofs are usually included in the class 8 textbooks, usually. Okay? So both of these basically mean parallelogram with a right angle. Okay. Is there any other comes to your mind?
They are having two right angle triangle. Split.
Two right angles. Any two right angles? Any two angles are right angles?
Two right angle triangle.
Okay, if you put any two angles are right
No,
angle,
it's-
then there is going to be an issue. I'm just trying to find the shape that will do the job. And I know it is here somewhere. As usual, you don't find things when you look for it. Oh no, I know where it is. It's, okay, got it. Okay, consider this shape. Okay. It has two right angles, the base angles, the bottommost angles are right angles. Is it a parallel, is it a rectangle?
It's a two right angle triangle, and they are same.
Wait. We are talking about quadrilaterals. Why are you bringing in triangles? See, so this is an example that if the right angles are opposite each other, adjacent to each other, then it is not guaranteed that it is going to be a rectangle, right? As you can see that this is very clearly a trapezium, not a rectangle. Because the remaining angles, they're supplementary, not necessarily right angles. The one is an acute angle, another is an obtuse angle. Now, if you want the opposite angles to be right angle, okay, let's say you are not satisfied with adjacent angles. Why not? Let's try opposite angles. Okay, so let's actually take a couple of right triangles and then try to see what happens. Oops. Okay. Now this shape, it is made of two right triangles. So, but again, the remaining two angles, so opposite angles are right triangle, but the other two angles are not right angles. Okay. So just having two angles equal, two angles right angle is not helping. Can you see that?
Yes.
Okay. Now, if you say, okay, what about three angles are right angles? Now, the moment three angles are right angles, what happens to the fourth angle?
Right angle.
So then it becomes like the first one, right? All angles are equal. Okay. Usually these are the two main ones. If you can come up with a third one, we can definitely discuss. Okay, now what about rhombus? How would you like to define a rhombus?
All sides are equal.
Yes, that is one possibility. Okay, what else?
Opposite sides are parallel.
Again, if you say opposite sides are parallel, then you're talking about a parallelogram, and that's not enough. So again, you need to have parallelogram and or parallelogram with. This was not clear. Can you repeat, please?
Opposite sides are parallel.
Yeah, opposite sides parallel means it is a parallelogram. But then that's not enough. Parallelogram and something you have to say, because see, we have already got a parallelogram over here, right? This one.
Parallelogram with all sides equal.
So if you say parallelogram with all sides equal, just the all sides equal is enough. So how can you say less if you are already giving the parallelogram part? We can say with adjacent okay. If one pair of adjacent sides are equal, then automatically that takes care of everything. Okay. So let me just annotate and illustrate it out. Okay. So we already know that opposite sides are equal for a parallelogram. Right? Now, if we say one pair of adjacent sides are equal, then this side will be equal to, let's say this side. Okay. Now, the moment that happens, this side will become equal to this side. Right? And you see that all four have become equal. Okay. Is that clear?
Yes.
Yeah. Now, when it comes to rhombus, both the definition coming from parallelogram and the definition that all sides are equal, both are kind of known. Okay. And people usually never object to either one of them. Some textbook will have all sides equal, some will have parallelogram with equal adjacent sides or something. When it comes to rectangle, usually all angles are equal is not mentioned. Okay. But it is, as you can understand, it is a perfectly valid definition. Okay. Also, when we define many quadrilaterals in particular have a lot of equivalent properties. I mean, parallelogram is the most well-known of them. So there are many ways, for example, how you can define a parallelogram. So then there is a question, which one should we take as definition and which one should be properties? Usual notion is that definition should be something that is easy to construct. So it should be mostly related to sides and angles so that you can construct it based on the definition. And then you can extrapolate the properties. So that way, as much, I mean, if you can define something as much as possible in terms of sides and angles, the better. And therefore, you know, diagonals will very rarely enter definitions. Okay. Because unless you draw it, you know, how do you know anything about the diagonal? So, I mean, broadly speaking, for parallelogram, what is taken as a definition, okay, is that it has two pairs of parallel sides. Now, two pairs of equal opposite sides would have been a very, very good candidate. And I don't know why that is not the case. Okay, because when you have to construct parallelograms, that is the most useful. And you can deduce from that all the properties and that, you know, both pairs of opposite sides are parallel, etc. So historically, why you know, two pairs of parallel side is taken as definition, I don't know. Okay. And I will be very interested to know why that is the definition instead of two pairs of equal sides. Okay. So if anybody can find anything on this, do share. I would be looking forward to that. Okay. Now let us look at some pictures. Oh, before that, one thing is very important. Okay. We'll come to that when we, okay, now we have the pictures. Oops, sorry. Okay. Now, there are two sets of quadrilaterals, and there are rectangles and there are rhombuses. Now, is it correct to say that adjacent sides of a rectangle are unequal?
No.
Exactly, because many of you did mention it, and that is not necessarily true. Okay. One exercise which you can do, and you can try to do it even with children, you can ask them to do. It works out very nicely in GeoGebra. Not sure if how it will work in Scratch, it probably will. That you ask them to draw a rectangle, say, okay? And they have to draw it in such a way so that even when you drag any of the vertices, the shape will remain a rectangle. Okay, it may change its orientation, you know, some side may become bigger or smaller, but the shape should still remain a rectangle. Okay, now it is quite possible that you may not be able to move all the vertices, but whichever vertex you are allowed to move, and at least I would say 2 of the vertices should be allowed to move, if not 3. Okay. You should be able to change the orientation of the shape or make the size bigger, smaller, etc., etc. But throughout it should remain a rectangle. Okay. So how do you construct that? Okay. And rectangle is just an example. Okay. The thing is, what really came out, I don't know how many of you attended the webinar we had last week. This was discussed there. When children did that, they automatically realized that sometimes the rectangle is going to become a square if you adjust the size accordingly. So that the square is a particular rectangle or a special rectangle automatically becomes clear to the children. Okay. Same thing you can do with rhombus or any shape. So when you try to draw the general version, okay, without specifying, okay, this is 3 centimeter or 5 centimeter with an angle of 70 degrees in between, then you are drawing a parallelogram, and no matter how you shift the vertices, etc., it should always remain a parallelogram. And you can make it into a rectangle or a rhombus or a square, depending upon how, you know, you can play around that way. So that's a good exercise for both you and for the children. Okay. Because when you are trying to construct, what are the things that you are using? Okay. Okay. Now, so similarly, can we say that the angles of a rhombus, let's say consecutive adjacent angles of a rhombus are unequal? Must be unequal.
No.
Or that diagonals of a rhombus must be unequal.
No.
Okay, so be careful of, you know, saying those kind of things. Okay. Why it should not be said will become more clear when you read that article, which I'll share. Okay, now, as I said, definition of parallelogram is kind of set on stone. So I'll just write it out. Okay, now adjacent sides obviously cannot be parallel, so I'm not writing opposite sides explicitly. And since it's a quadrilateral, sides have to be either opposite or adjacent. There is no other choice. For a pentagon, hexagon, etc., of course, you need to specify. Okay. Now, how do you define a kite?
Adjacent sides are equal.
How many pairs?
2 pairs.
So, quad with 2 pairs of equal adjacent sides. Okay, so that's the I mean, as a definition, that's the most straightforward one. Okay, there are other ways to characterize a kite. Okay, but that cannot be definition. That can be property. Okay.
The angles. Hello.
You will have to repeat that.
Angles are equal where two adjacent sides meet.
Okay. You are okay. So let's just quickly draw a. Okay, here's a kite. Okay, let me just copy paste one of the kites and then talk. Okay, and let's give it some name. Okay, let me be a bit lazy because I've already got ABCDs somewhere. I'm just going to use them. Oops, okay, there. Okay, so here is a quad with ABCD. So which side should be equal? AB and
AD.
right. And then the other pair will be BC and CD. Okay. Okay. So is it clear now? So whenever you are saying that something is a kite, a quadrilateral is a kite, it's a good idea immediately to label that quadrilateral A, B, C, D, P, Q, R, S, whatever your choice is, and mention which pairs are equal. It's a very, very good idea because otherwise you won't be able to progress further with the proof. And we'll get to that. Okay. Now, angles are equal where two adjacent sides meet. First of all, which two adjacent sides? Two unequal adjacent sides? Well, again, it can be a rhombus. So, you know, that needs to be sharpened out. Which angles are equal? Okay. See, the moment you label it, then it can become very easy to say which angles. Okay. So you can say, now you can easily say, so angle B is equal to angle D. Okay, then it is very, very clear. Okay, so it's always a good idea when you are, talking, use a quadrilateral whose vertices have been labeled and then talk in terms of that. Okay. Okay, and of course, this equal angles, this is a property. Okay, not a definition, not part of the definition. Okay, now, so again, you can see that within parallelogram, the special parallelograms have been included. Within kite, first of all, there are lots of types of kites that have been included with different orientations and the special ones. Okay. There is a misconception, and the reason I have made this picture is to counter that. Now, if you look at there are two diagonals, right? Which diagonal is the line of symmetry?
AC.
AC is the line of symmetry. Now, is this true or false?
True.
True for this this kite. Is it true for any kite? What about this kite?
It may vary according to the shape we take.
If we have this second kite, okay, and let's name that also as ABCD the way we have done. So AC is the okay. Okay. Now for the second kite, is AC greater than BD?
No.
No.
Exactly. So therefore you cannot say this. Okay. But this is a misconception that many people have. That is because textbooks do not include picture of this kind of kite, and it can be made longer also. Okay. So this is where if you get children to draw a general kite whose vertices can be dragged, like this one, in this case, we drag the vertices, right? But I mean, this way won't give you full freedom. I mean, you cannot change everything that you can. If you draw it on GeoGebra or maybe in Scratch, then it actually gives you full freedom, and you can, make it stretch and make it longer, whatever. You can do all of that with it. And at every stage, it will remain a kite, and you basically get to see, okay, a kite can be so many different ways. And it is very important that when you are introducing any concept, you give the widest possible exposure. Otherwise, there are misconceptions like this one, which many teachers have. Okay, it's a good idea to give the widest possible exposure so that they don't form. Okay, so that's why how you will see that there are lot of types of kites. Okay. What is the definition of a trapezium?
One pair of opposite sides of a
Yes. Okay. Now, it does not say anything whether the other pair is parallel or not. It can be parallel, it may not be. If you are talking about a trapezium, you can never say that the other pair is not parallel. Okay. And I'm not going to go into the definition of isosceles trapezium. I want you to read the article and then get into that. Okay. Kite and isosceles trapeziums were ignored topics in school mathematics. It is very unfortunate for kite because it is used quite a bit in standard constructions. Constructions which are there in class 6 and also later on. Even now, the NCERT textbook doesn't do complete justice to kites. And isosceles trapezium is even more ignored. But they are quite interesting when you look at them from symmetry and various other perspectives. So I would like you to read the article and then we will come back to it. Okay. So these are trapeziums. Okay. So you should be able to find all kinds of special trapeziums here, including an isosceles trapezium. I've deliberately not drawn the isosceles trapezium because that will be next time. Okay. Okay. Now, we need to show that rhombus is a kite. Now, here is a rhombus. So what do we know about the rhombus? And you can take any of the definition. That is perfectly fine. So if we use the first definition, okay, what do we get? This is the first definition, quad with all sides equal. Okay. So if we take that, what do we get here? It's too obvious, but please somebody key it in or unmute and tell.
AB equal to BC equal to CD equal to DA.
Exactly. Okay, DA, AD doesn't matter. Now, what do we need to show or prove? We need to show it's a kite, right? We need to show that ABCD is a kite. In other words, so what do we need to show? What is remember the definition of a kite. What do we need to show?
AB equal to BC and AD equal to DC.
Now, this is correct, but there is another possibility. Okay, the labeling could have been different. So AB could have been equal to AD and we can have BC equal to CD. Both are possible. Okay, in both cases, you will get adjacent sides.
Yes.
Now, if we take this definition of rhombus, have you already showed that? Yes or no?
Please repeat the question.
So, given this thing, okay, that all sides are equal, AB equal to BC equal to CD equal to DA. Haven't we already showed this?
Yes.
Or even this?
Yes.
See, it's that obvious. I mean, if you think about it, if you think from a language perspective, okay, this is all sides equal, okay? And for a kite, it is two pairs of equal adjacent sides, right? Now, if all sides are equal, obviously you will get two pairs of equal adjacent sides. Right?
Yes.
They're all equal. So there is no space for any inequality here. So you can say follows directly from these definitions. Okay, and that's why this definition is important. Now, and I'm going to use a different color now. If you take that parallelogram, the definition is parallelogram with a pair of equal adjacent sides, right? Then you need to do a little bit more work. You need to say that, okay, so which ones are equal? Let's say you take AB equal to BC, and you already know AB is equal to opposite side CD. You know BC is, okay. Okay, let's say equal adjacent sides are AB equal to BC. Okay. Now from parallelogram, you get that AB opposite sides are equal. Therefore, AB equal to CD and AD equal to BC, right? So now when you combine them, you get AB equal to BC equal to AD, right? And you already know that is equal to CD, right? So you got all of them to be equal. Okay. But you have to do that work. And then you cannot say follows directly from this definition. Once you come to this state, then automatically you have shown these two. Okay. So this is a very, very straight, direct, simple one. Okay, no need to go into angles, diagonals, and all those properties. Much, much simpler than what some of you have done. Okay. Now, any question with respect to this? Okay. So now let's look at this one. Now, when you are trying to identify a quad that is a kite and a parallelogram, you have to kind of draw a general quadrilateral, label it, and then figure out the properties. Now, it is a kite. So you have to say that which sides are equal adjacent pairs. So let's say AB equal to which one? AD or BC? Pick. Doesn't matter which one. You have full freedom.
AD.
Okay. And we have BC equal to CD. Okay. Now, when we say parallelogram, obviously we know AB parallel to CD and AD parallel to BC. Okay. Yeah. Okay. Okay. Technically, maybe I should do it DC, but doesn't really matter too much. Now, again, from parallelogram, we can get things in terms of opposite sides being equal. So we can say that AB equals CD and AD equals BC, right? Okay, so now what do we get? So this is the part we have got from the parallelogram. Okay, so now, okay, and it's a good idea to label this. Okay, so this is, let's say, 1, and this is 2, and 2 implies this, which is 3. Okay, now see, 1 is about equality of sides. 3 is also about equality of sides. So if we combine 1 and 3, what do we get?
AB equal to CD.
We get AB equal to CD. Okay. And CD is equal to what? CD is equal to BC.
Yes.
Okay. Oops. And BC is equal to what?
AD.
Now, all sides are equal, right? So let's call this 4. So now, ABCD is what kind of a quadrilateral?
So rhombus.
Yep. So you see, it's not a long proof. It's a very, very short proof. But what is critical is that you need to draw a quadrilateral, label its sides, and then, actually say, okay, this is equal to this is parallel to this, therefore this is equal to this, blah, blah, blah. Okay. And that's it, we're done. Okay. So why don't we try the next one? Okay. Sorry, this should be trapezium. Want to try it now? So I'm assuming you can go with the previous one. So let's take this. Okay. Now, for a trapezium, you have to choose which two sides you want to be equal. Sorry, parallel.
AB and DC.
Okay, so now in this case, because, okay, so let me annotate a bit. AB equal to AD and okay. Now we want AB to be parallel to DC. Okay. Now instead, if we had taken AD parallel to BC, would it have been a very different situation? What do you think? Yes, no? If this is a class, you can ask half the children to take AB equal parallel to DC and the other half to do AD parallel to BC and figure it out. Okay. For you, I mean, it is a kite, right? So if it is a kite, it has a line of symmetry which will go through here, AC. Now, if we had taken AD parallel to BC, it would have been just a mirror reflection of the situation we are talking about. Is that part clear? It's as if like, you know, we have just flipped the picture. Okay. Now, you don't need to be convinced by me here. Just take AD parallel to BC and see what happens. Okay, if you get something drastically different or not. Okay. Okay. So let's continue with this. Okay. So we have got this. Now what do we get? And there may be many, many ways to go from here. Not just one. Let's say ABCD is a kite. So from there, what can we get? In terms of, you know, congruent triangles, equal angles, blah, 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 whatever, what can we get? Even I have drawn the line of symmetry also. So what can we say about, let's say equal angles?
Angle B and D are equal.
Okay. Okay, what else? Which other angles are equal?
Angle CAB and CAD are equal.
CAB equals CAD, good. Okay. And one more, I think.
ACB and ACD, right? Are
Yep.
equal.
Yeah. Okay. We don't know which one we will use. So let's just put everything in there. Okay. Okay. I'm being lazy and not putting in the angle sign because it's more difficult here. It doesn't allow math type. Okay. Now, so we get this from. Okay. Okay. Now, we know that these are parallel, right? AB is parallel to CD. Now, when you have two lines parallel and you have AC as the transversal, right? So then what can you say? AB is parallel to CD and AC is the transversal. So can we get something? Parallel lines, transversal. You can annotate or show. There. Okay, so we get the two more angles equal. CAB equals ACD. Okay. So then, now, if you take 3 and 4, then you get that CAB is equal to both ACD and CAD. So ACD is equal to CAD. Right? So in this triangle CAD, you have two angles equal. Okay? So if two angles are equal, then what can we say? No, that we cannot say. Hello? No, the last one we cannot say because AD, yeah, if you had taken AD parallel to BC, then that would have been the case. Yes. But not right now. So for now, I'm going to erase those two. Okay, now you have erased everything. We definitely do want those lines. Yeah, so I'll just keep the equal angle. So this angle is equal to this, and it has now turned out to be equal to this. Okay. So in this triangle ACD, we have got two equal angles. What does that mean in terms of sides?
Sides AD and CD are same.
Exactly. So see, AD is the side opposite to ACD, and that will be equal to the side opposite to CAD. So side opposite to CAD is CD, So they are equal. Now, so we have got these two equal. Now, if we combine 6 and 1, what do we get?
AB equal to CD.
So we get AB equal to AD equal to CD equal to
BC.
there you go.
BC.
Sorry.
Rhombus.
Yes. Now, notice one thing. When we taken it to be parallelogram, we got a rhombus. When it took it as a trapezium, we again got a rhombus. Right? So, kite and a trapezium, just one pair of parallel side is enough. You don't need both pairs to be parallel. Okay? In a sense, as soon as one pair becomes parallel, because of the symmetry, automatically the other pair has to become parallel. Okay? From a symmetry perspective, you can think of it that way. Okay? So that's where symmetry is kind of quite powerful if you use it properly. Okay? So I was hoping to complete this today, and we did it. So now this is the homework. Okay, I'm going to put this on the chat also, the link. I'll share the PPT with you in few minutes as soon as we are done here. So define these things. Again, the only quadrilateral which I have not included here is parallelogram. Only convex quadrilateral. Okay, because parallelogram is already too important, too well defined, too much already in the syllabus. Okay, everybody knows what a parallelogram is. Okay, it dominates class 8 syllabus. Okay, at the expense of others. Okay, so now that you have seen how to prove these things, now take a look at, now only when you define this guy can you do the next step. Okay, so do that part. Okay, and these two are similar. These are all involving so today we have dealt with the kite stuff, and the homework is to deal with the isosceles trapezium stuff. Okay, so that's all from my end. Any question, anything? I'm going to stop. Did I share the quadrilateral pull-out with you?
Yes.
Okay, so there are some exercises there in terms of, similar to, if it is a this and that, what kind of quadrilateral is this, or those kind of things. So do take a look. Okay, now for children, initially it is just fun and to identify stuff. But for you, I think it is going to be a good idea to actually try to prove things rigorously. Okay, so try to sink in your teeth in those. Okay, that's all from my end. See you next week.
Thank you, Swati. Bye.
Bye.
Thank you.
Thank you.